So for today, we're going to start by doing this worksheet once with data that I give you that's fairly easy. We're going to say if a kid was 50 inches tall, they're going to have a shoe size of a 5, and I think you'll see the correlation there. I know this isn't a realistic, exact correct number, but if you were 54 inches tall, let's say that you had a size 6. 55 inches tall, you'd still have a size 6. And the shoes probably don't grow that much because you go 1 inch taller. Okay. So let's say we had 60 goes up to a 7. Now, we could give you more data, but I just feel like it's kind of cruel to have, tons of data to type in. So this is good enough. This will get you a box plot. It'll get you everything you need. So if you haven't already, copy these down. 50, 54, 55, 60, and 5, 6, 6, 7. Now, there's mean, there's median, there's mode, and there's range. If I just look at these numbers here, just the 5, the 6, and the 6, and the 7, just those. Would you please type those in? Wait, I'm wrong. I'm just going to have you say it to me. Do you know which the middle number is? 5, 6, 6, 7? What's the middle number? 6. So that's the median. Do you know that for the average, you would just type them all in and do that one variable stats thing? Let's try it. Go ahead and put those all in on list 1. Use stat, edit. Is there anybody that needs to borrow a calculator at this point? If so, please come up. Pausing while you do that. So as you put these numbers into L1, 5, 6, 6, 7, your calculator under 1 var stats, you do stat calculate 1 var stats, stat calc 1 var stats. Under 1 var stats, it's got these answers, except there might be 1 or 2 of them that you'll have to get out of your head. There's 5 numbers that go where these 5 red arrows are. All right. I'm going to walk around and see if you have found 1 var stats. Have that 1 var stats up on your screen when I get there. All right, so we got everybody with, and the mean is that one that says X bar. The mean is the average, and that is 6. That was pretty easy. What's the mode? That's not on the list. How are you supposed to know what the mode is? It's the most common one. Do you see how there's 2 6s? Of our list, isn't that the most common? Therefore, it's 6. Now, you can make it more complicated. What if there had been 2 7s also? Then it's called bimodal. If there's 2 things that are tied, you just list both of them. So if there had been 2 6s and 2 7s, you would have listed 6 and 7 as the mode. But in this case, it's just 6. What is the median? Well, there's a little thing called MED, M-E-D. Vivian, would you read me what the median was? 6. And it makes sense. Median's in the middle, and the middle between those two is also a 6. All right, the 5-number summary is smallest to the biggest. There's 5 numbers there. Let's go with Victoria. What are the 5 numbers?
The minimum is 5. So
5.
Q1 is 5.5.
5.5. The median?
6.
6.
And Q3 6.5.
6.5. And then the last one?
Is 7.
7. Okay, good. Now here's a follow-up question that could be on the test. Pay attention. Where is 50% of the data represented? Well, there's a lot of places that 50% is represented. Would you agree that from here to here, that's 50% of the data, isn't it? And then the bottom is, that's another 50% of the data. But where's the third place you can get 50% of the data? Yes? The center, that box. So from 5.5 to 6.5, that is the middle 50% of the data. Okay. Each of these little areas is 25. That's 25%. This is 25%. This is 25%. And that's 25% of the data. All right. The last thing is called the interquartile range. This is Q1. This is Q3. What's the range between 5.5 and 6.5? You say, what is the range? You subtract the two to get the range. So the range is 6.5 minus 5.5. The interquartile range would be 1. What is the range of the whole thing? 7 minus 5, which is 2. Again, the range is not on your list. You have to do that one out of your head. You got to know how to do range by just taking your biggest number minus your smallest number. So 7 minus 5, the range of that one is 2. Okay, good. Now how about the box plot? That's this. The only thing I want to talk about that isn't obvious is on the test, we will make you have your box plot be lined up with a number line. So if you have a number line, and you can start with anything you want, but your number line is going to be like regular, like this, 5, 6, 7, 8, 9. You know, number lines have to be like orderly. You can't jump around for your numbers. So then if I was going to fit my box plot onto the number line, I know that it's supposed to start at 5, so I would have a dot here. And then I go to 5.5, which is right there. Then this other end of the box here is at 6.5, so that's here. And then I can draw my box. And then the 7 is where it goes to, so it stops right there. There is my box plot, but on a number line. See how these have to line up nice? 5.5 lines up with 5.5, 6.5 lines up with 6.5, and 7 lines up with 7. Okay? All right. Next thing is, we already talked about range and interquartile range. That was, again, the range was 2, and the interquartile range was 6.5 minus 5.5, so that was 1. The standard deviation. Look on your little list and find this weird-looking little symbol. Find that one. Did you see that one in the list? Under one var stats? Okay. Rena, can you tell me what that is?
0.7.
All right. Now, what will you have to know about standard deviation? Please write this down so you'll remember it better. It's the average difference from the average. Do you agree that not everybody in here is average? Right? So if we take your shoe size, you're not going to just be average. You're going to probably be a little above it or a little below it. So you all have a difference from the average. If the standard deviation is a little more complicated than this, but a good way to think of it is, it's like the average difference from the average. So if in here, the typical kid was 1.5 sizes away from the average shoe size, then our standard deviation would be 1.5. This 0.7 means the average kid was 0.7 away from the average. All right, so let me make sure that you get this in the context of your class versus, let's say, the math team. For your class, if we took your scores on the final, would you agree that there'd probably be a fairly big spread of scores? Like some kids are going to get like a perfect 100, but there'll be a lot of kids that get more like, I don't know, 85. And there'll be some kids that get as low as like a 60. Okay, so the scores might be like this. A ton of scores around there, and then just one person way down here. You get they're kind of clustered around the 85. Okay, so that standard deviation might be like maybe 7 points. The average kid was 7 away from the average. Now, if you had the math team take our final, do you get that they're all like math geniuses? If they took our final, do you get they'd almost all get 100, or maybe a couple kids that get 99? Do you get that would be like super clustered all right in here? All 20 kids on the math team would score right almost at 100. Their standard deviation would only be maybe 1 point away from the average. Because they would be so, their average score would be like 100, and they'd all be about the same. So standard deviations that are really small, they're all about the same. This is more of a normal standard deviation where it's spread out a little bit. The one I gave you in class that was an interesting one to me anyways is IQ scores. And this was real. The average IQ is 100, and the standard deviation is 15. In the real world, a lot of people are not right at 100 IQ. The average person is about 15 points away from the 100. That doesn't mean everybody's at 115 or 85, but those are the most common two, because those are one standard deviation away. Those are the ones, they're not the most common IQ scores, I shouldn't say that. But there's a lot of people that'll fall in this range. Okay, so moral of the story, this is fairly spread out. Do you get if I took the IQs in the genius class? There's little kids that come here in about fourth grade, where they have this class of kids that literally you have to qualify as a genius IQ. Your IQ has to be super high to be in this class. There's a class of kids. And that class, they might have a standard deviation of only 1 because they're all super smart, and therefore they're all clustered really close to that high genius kind of IQ. All right, so this is really close together, and this is more spread out. Any questions about standard deviation? That's a thing that's going to be on the test. All right. So, next thing, let's go back to our little guided review worksheet here. The correlation coefficient. All right. So then we need to go up and put this into the calculator as a list of 2 things. So, would you please delete them out of your calculator? Because we need to put this in as L1 now, and this in as L2. If you're having trouble deleting them out of your list, just hit Del, D-E-L, the delete key, and move the arrow to the next number and hit delete. Move the arrow again, hit delete. Get them all deleted out. And then put in the data where the red numbers there are your L1 numbers, and the black numbers are your L2 numbers. Next, if this calculator is new to you, you want to put your stat diagnostics on. That was under, some people it's on mode, but for most people it's under the catalog button. If you don't get an R value, you know, if at the end you do the linear regression thing and there's no R value, it means you haven't turned stat diagnostics on yet. If you're on an iPad, you have to do it every single time because that website defaults back to not being in diagnostics mode. All right, so that's under catalog, diagnostics on. All right, why do we need that? Because it'll tell us the R value. So type these all in and then do a stat calculate linreg, and there's 3 kinds of linreg. Linreg of the AX plus B kind. That will answer these last 3 questions. The prediction, I'm going to ask you at the end after you've got the equation. What if the person is this tall? How big should their shoe size be? That'll be the prediction thing. All right, I'm gonna pause for a second and walk around and make sure you know how to do the linear regression and the correlation coefficient. Made sure that everybody had it on their screen, which is great, but can you write the equation? Y equals, can you interpret what it says on the screen and write it? Well, you need the A first. Christian, what's the A value? 0.197. If you're not sure, use about 3 decimal places and it'll tell you if it wants you to be more specific. But if you're not sure, use a few, use 3 at least to try to be more accurate. Plus, and then let's go with Amir. What's the B number here?
4.79.
79?
Yeah.
Thank you. Can anybody verify that? That look right to you? Uh-oh. Riker, yours is different?
I think it's negative.
Oh, is it negative?
Oh, yeah.
Ah, okay. That's an easy mistakes to make. I'm human. You're human. There we go. Okay, so now here's the prediction part. Do you get this was about height and shoe size? Which one was the X? Well, which one was the L1? These numbers are your X numbers. So if I give you another height, like, for instance, something bigger than 60, like 65, would you please put in 65 for the X? You'll have to use a calculator, but there's no app for this. You just have to know what happens and figure out the shoe size for that. If I use 65 for a height, what would it be? All right, Veda, what did you get? 8.01 what? 5, okay. I would think if I wanted to round to there to a whole shoe size, or sorry, 1 decimal place, 8.0. Raise your hand if you had something that would have rounded to 8. Cool, I think you get it then. So, I looked over the test and I thought, what are some last minute tips I would want to give you? And here's some thoughts I had. If I asked you to draw a scatter plot that showed a positive correlation, can you put a bunch of dots and just show a positive correlation? That's all I meant. Did I say it had to be perfect? No. If it had to be perfect, they would be in a straight line. But that shows positive correlation. How about weak negative correlation? Tried to putting dots out for that. Have the dots be fairly far apart but going down. Does that make sense to you? Okay, that's how you do positive or negative. Positive goes up as you read from left to right. This is going down, so it's negative. And weaker or stronger is how close it is to being a straight line. All right. Next one. Imagine it's IQs again, but on this class, I do the IQ, and the average is 103. And the standard deviation is 7. Meaning you're closer together than out in the real world, clustered a little more. Then you should be able to tell me, what are these two numbers? And you can keep going if you want to and go out another 2 standard deviations, but. And then, when we give you this chart, which we will, if this is 34%, and this is 13.5%, and this is 2.35%, and then the last one, if you have any humans that are way out there, they're only in the 0.15%, not even 1%, 0.15%. if I said, what percent of people are above 110? You should be like, oh, 110, that's what this was. Because you add the standard deviation to it, that's 110. If I subtract the 7, it'd be 96 right here. If I said, what percent of people are at 110 or above, you'd go, okay, well, I'm just going to add up all of those. That plus that plus that. That's what percent of people are at 110 or more. 13.5 plus 2.35 plus 0.15. It'll end up being 16% because I added up that plus that plus that. Okay. I don't feel like it's that hard of a problem, but let's just check. I'm going to give you one more like that. Say it's my Super Genius class I teach here. And they're at 110 average, and their standard deviation. There's a lot of super smart kids in there, especially, yeah, I'm not going to name an hour, but I have 1 hour where I have a lot of super smart kids in there. So let's say the standard deviation is 10. Would you be able to tell me what percent of kids are at 100 or less? Of course, this is just made up numbers, but if 110 is my average and the standard deviation's 10, you should know what these two numbers are here and here. And I will write those percentages on the board again. 34%, 34%. You'll only need them in this direction, so 13.5%, 2.35%, 0.15. Dashiell, can you tell me what these circle numbers are that are important?
Are they like,
What's that one?
is that the Q1?
Nope.
Or is,
The average is 110, and then you subtract the standard deviation. So what number goes here?
oh, 100.
There you go. That's 100. What about this one?
120.
Yep. Okay, and then if you wanted to do another standard deviation out, you'd subtract another 10, so this would be 90, and then this would be 80. Because you keep going out, you keep going one more standard deviation. Okay, then I said, what percent are at 100 or less? Do you guys know I meant that number? Wait, I better use a different color. That number, and that number, and that number, all added together. That added up to 13 plus 2, 14, 15, plus the decimals, 16%. Who had 16% before I said it? Nice job. That was from the 3 blue numbers added up. All right. And the last thing that I want you to be able to get some help on is what it means to have a correlation that's strong or weak. .86, is that a positive or a negative correlation? Positive. Okay. if I said this is positive and strong, I might call it strong positive correlation. What does that mean? If I gave you something that doesn't correlate, you might understand better. Would you think that how bright it is outside and how hungry you are, do you think those are automatically correlated? No, because they don't go together. Like, just because it's bright doesn't mean I'm hungry. Maybe I just ate a minute ago. So when you hear correlation, I would put in your head goes together. All right? So if I said, do you think studying your vocab words and your score on the vocab test, do you think they're correlated? Yeah. You study the words, you'll do better on the test. The one goes with the other. Goes with is the key word. Okay, so if I asked you to describe what does an R value of 0.86 mean to you? You should be like, okay, there's a strong, because it's close to 1. Positive correlation means that those things go together. And it's strong means that they go together strongly. So what if I said, I did the R value of kids studying in red light compared to kids that studied in normal light. And I found that the R value was negative 0.4. Describe in words what studying in red light did for people. Yes?
The red light made them do worse.
Yep. It was a negative. So use the words negative and positive, and use the words strong and weak, and use the word correlation.
There's a negative weak correlation between studying.
There's a negative weak correlation between studying in or performance and red light. Might be a way to say it. All right. Yes.
Can we say if it was under 5.5%, then it wasn't a correlation?
Yeah, I probably should have said 0.5. Now I can say that it's weak correlation. Now, don't worry, I'm not going to be that fussy on this. Because what's exactly super strong versus medium strong, that's really a judgment call. It's like an opinion. If you'd study in a stats class, they can give you exact numbers, but we're not going to go that deep. This is just 1 week of stats in an Algebra 2 class. So as long as you know that ones that are 1, which is like a perfect correlation. So if it came out negative 1, it would mean the more time you spent studying in red light, the worse you did. Automatic, locked in, super correlated. In the real world, there's almost no things that are at a negative 1. There are some things that are like a negative 0.9, and that's strong negative correlation. Like, you do this, the other thing will go down. All right, so I think that covers it. That's everything you'd have to know for the test tomorrow. So I want to give you the same worksheet that I gave you before, but I want to give you new numbers, and I think you should just do the same worksheet with these numbers now. So erase everything out. And here's your numbers that I want you to use. 60, 65, 70, and 75. And we're going to go 8, 9, 9.5, and 10. We're just going to use this 4 data sets, those 4 combos. I'm supposed to fill this thing up, but it's dumb to make you put in that many numbers. It's just pain in the butt. More likely to just type something wrong. Now, use those numbers, and when they're asking about the mean, the median, the mode, the 5-number summary, the box plot, do all of those for the top line, for that line. Okay? All right. It's only when you get to here, to here, when you're going to need to do both. You only need the blue numbers up until, you only need the black numbers. They only kick in once you need these last few. Oh, one more thing. Write down your prediction. Your prediction is, if I give you, if a height of 50 all right, so I will use those same numbers as you. I will make a key for this, and then I will post it so you can see if you're doing it right. Remember, all of these questions, you're only using the blue numbers all the way up to there. All right, there's a good review of stats, and tomorrow's the test, and it's your last test. I really encourage you to do this like little extra review practice worksheet that I just made for you. It'll really help you get ready, and hopefully kids that are absent today end up watching the video so that they can know those last little tips I had about what correlation and how correlation means things that go together or are connected. And yeah, I think it's going to be a good test. That's all I got for you for today.